Alright, this is part 5 of our lesson on graphing rational functions. And let's pick up here with number 6. Alright, let us first deal with the horizontal asymptote, if there is one. For the horizontal asymptote, we look at the degree. If the degree of the numerator is less than the denominator, that means the horizontal asymptote will be y equals 0. That means there will be no slant asymptote. To have a slant asymptote, the top degree has to be higher by 1. Now let's talk about vertical asymptotes and wholes. To see what's going on there, we need to factor the numerator and the denominator. So let's do that now. Alright, if I factor the numerator, alright, that looks like something that would probably factor as a binomial times a binomial. X squared is going to be x times x. 12 is either going to be 3 times 4, or it'll be 2 times 6, or it'll be 1 times 12. Alright, considering that the middle is -1, I'm betting on 3 times 4. Okay, now inner plus outer must equal the middle. Inner, right now, I've got 3x, and outer, I've got 4x. If I want to get a -1 middle, I need a +3 and a -4. So here's my +3, and here's my -4. Luckily, that also gives me -12. A positive times a negative is a negative. So that means this is now factored correctly. The denominator has a common factor, alright, of x. So I'm going to pull out that GCF of x. And that's going to leave behind x squared minus 16. But this is the difference of two squares. So this is going to factor as x plus 4 times x minus 4. Now, what if I were to move this out of the way? Would that scare you? Would that startle you? Okay, so I've got my x. I'm just going to take this x squared minus 16 and factor that as x plus 4 times x minus 4. Okay? So now here's my new function. So usually I look at the denominator for my vertical asymptotes. But before you do that, you have to see if any factors will cancel out, because any factor that cancels out is going to give you a whole instead of an asymptote. So these canceled out. So that means this x minus 4 business, okay, if I set that equal to 0 and solve, okay, this x equals 4 is not a vertical asymptote. This is going to give me a whole. Alright, there will be a whole at 4 comma something. Alright, so let's go ahead and write that down. There will be a whole at 4 comma something. Now I want the y value to go with it. To get that y value, I'm going to use my calculator, and I'm going to put in the part of the function that did not cancel out. And I'll use that to find the y value. So x plus 3 over x plus 4 times x. Alright, table it up. Fraction mode. So I had, what did I have? X plus 3 over x times x plus 4. Okay, x plus 3 over x times x plus 4. That's right. Okay, and our whole is at 4 comma something. So let's investigate, but let's start at 4 since that's what we want to know about. Okay, at 4 we have 7 over 32. So for right now I'm just going to write that down. 7 over 32. When it comes time to graph that, it'd be useful to know the decimal, but obviously it's something very small. Okay, so it's about 0.2. So please write your answer as a fraction, because that is exact. But maybe underneath it or something, put 0.2 for graphing purposes. Okay, so that's a whole. Now these other things, okay, the x and the x plus 4, these are going to give me vertical asymptotes. So if I set them equal to 0, I have x equals 0, so that's a vertical asymptote right there. Okay, and then I will have, if I set x plus 4 equal to 0 and subtract, then I get x equals negative 4. And that is a vertical asymptote. So I do have two vertical asymptotes, all right, at 0 and negative 4. So x equals 0, x equals negative 4. Okay. Now it is time to graph some stuff. So let's go ahead and graph these asymptotes and the whole. Alright, so here are my vertical asymptotes at negative 4 and, wait, I think I messed up. Nope, vertical asymptotes at 0 and negative 4, horizontal asymptote at 0, and my whole at 4 comma 7 over 32, which is about 0.2. That's just a little bit above the x-axis. So that's why I have a hole right here. Now, let's use our TI-30XS multi-view to graph a bunch of more points. Let's graph some to the left, some in the middle, some in the right. I like to get up real close to the asymptote, decimals away. So I'm definitely going to do like negative 4.5, negative 3.5, negative 0.5, positive 0.5. I always do that. I suggest you do the same. So if I look at the table, I've already got a bunch of good things happening here. What was I talking about? Let's start off at negative 6. I like to just kind of go left to right. Okay, at negative 6, we're at negative 1/4. So that's just a quarter of a square below the line. So negative 6, I'm at negative 1/4. It's like right here. Okay, what about negative 5? I'm at negative 2/5. Alright, so that's almost half a square down. Almost. Alright, I'm going to come back for the decimals afterwards. So I'm going to skip over to negative 3 next because I got the error there. At negative 3, we're at 0. Okay, so notice that that's right on the horizontal asymptote, but that's not a problem. Apparently you can touch the horizontal asymptote. It's just at the end the graph approaches it, but in the middle, apparently you can just disrespect the horizontal asymptote all you want. So don't worry about that. Let's keep going. Negative 2, I'm at negative 1/4. So that's just a bit below the line. And let's keep going. So at negative 1, I'm at negative 2/3. Okay, so that's like here. Alright, I'm gonna come back and look at these decimals afterward, but let's go ahead and pick up with positive 1 because I got the error, and that's 4/5. Okay, that's going to be almost up to positive 1.8. Okay, so it's going to be almost up there, and at 2 we're at almost half a square. Alright, 0.4 is almost halfway up. Almost. And then I already have my hole over there showing me how it goes. Now I'm going to go back and pick up all those decimals. That'll give me a better idea what's going on. I suggest you do the same. But for the decimals, alright, hit your table button again, hit enter again. Now this time, instead of doing the auto mode, I'm going to do the ask mode, because that way I can type in whatever I want. So I want to know what's going on really close to the asymptote. So on the left side, that's negative 4.5. So negative 4.5. Okay, on the right side, that's negative 3.5. So negative 3.5. Okay. Let's just deal with these two for right now. Wonder if I can just clear that out. No, that didn't do what I wanted it to do. Alright, so at negative 4.5, I have negative 2/3. Okay, which is like negative 0.7. So negative 2/3, that's still pretty darn close to the line, but it's like about here. Alright, what about the negative 3.5? That's 2/7. Okay, so that's pretty close to the line. It's like almost a third of the way up. So it's just going to be a little bit above the line, like right here. Okay, now let's look at negative 0.5 and positive 0.5. Alright, so negative 0.5 and positive 0.5. Okay, at negative 0.5 I have negative 2/5. Okay, that's like negative half a square. That's weird. Alright, at negative 0.5, oh, that's negative 5. That's a problem. Negative 0.5. That's what I meant to say. Okay, that makes more sense. Alright, so that's negative 1.4. Okay, so here's negative 1, negative 1.4 would be right about here. How about positive 0.5? Okay, that's 1.6. So positive 0.5, I have 1.6. Okay, so these values are all very close to 0, but I've seen enough to be confident that the graph is doing this type of thing. Okay, and in the middle, it must be doing the wave. Okay, leave that hole empty. Okay, so your graph should be looking something like that. Now, as you can see, I changed my mind about the way I wanted to format the answer box. Okay, I changed my mind. So next time I'm going to format it this way from the beginning. So I just want to know, is this graph continuous or discontinuous? Alright, continuous means it's unbroken. Discontinuous means it's broken into parts. Clearly this is discontinuous. I've got these three different, well, technically 4 different parts here. So this is definitely discontinuous. Okay, so I'm going to circle that. Now, as far as the specific discontinuities, alright, all of these asymptotes are discontinuities. Okay, so like these vertical asymptotes are non-removable. Okay, those are non-removable discontinuities. Same with the horizontal asymptote, non-removable. Okay, only the whole is considered a removable discontinuity. Alright, so this is how I'd like you to do it from now on. So the graph is discontinuous, but we can just label each one of the discontinuities as removable or non-removable. And if it's a whole, it's going to be removable. Everything else is going to, all the asymptotes will always be non-removable. And finally, let's go ahead and do the domain. Normally we would have our domain in 3 pieces on a graph like this. Okay, the left, the middle, and the right. However, this branch on the right, because of the whole, is actually separated into 2 parts. So really I'm going to have 4 parts to my domain. So the first part is from negative infinity to negative 4, because that's the asymptote. Okay, so domain, negative infinity to negative 4, union. And then the middle part, alright, it goes from asymptote to asymptote. So negative 4 to 0. Okay, negative 4 to 0. Union. Alright? Now, again, this is two parts I have to do. So this first part goes from 0 to 4. Alright, x values only, so 0 to 4. Union. And then it's going to pick up from there, so the last part goes from 4 to infinity. Alright, 4 to infinity. And we'll leave these as round parentheses to show that the whole itself is not included. Okay, 4 itself is not included. And that is it for problem number 6. Alright, and problem number 6 is once again taking up the whole time for the video. So I'm going to have to end this video here, and we'll pick up with number 7 on the next video. Alright, I'll see you on that next video.